सर ये breather वो done.
Just a minute.
सर थोड़ा
There in your email box, tanker notes. Please confirm if you have received.
No, sir.
Not received.
Yes, sir, not received.
I'll just reduce the size again for 1 minute and I will come back. Received, right?
हाँ जी.
Your email ID is okay with the ARI?
Yes, sir, I am receiving all other mails.
You received this flammable diagram and all this assessment also, Leah?
Sir,
Sir, I received.
Shall we proceed now? Alright, so we have already discussed quite a
Sir.
lot about...
sir, I have not yet received the mail. Can you please send it again?
I'll send it at the end of the lecture, okay? Then we'll by that time we are absolutely sure that we are not received. So I'll send it through the OneDrive next time if we are not received, okay? Alright, so boiler uptake. From there is a boiler uptake valve which is going to the scrubber tower. The IG, the flue gas, hot flue gas, dirty flue gas coming to the scrubber tower and dried. After that, it is going to the IG blower, and from the blower, it is going through the deck seal and non-return valve. Finally, it's going inside the cargo tank. That's how the inert gas is followed. Inert gas path is followed. In the process, you have PV breaker as a safety device. You have a breather valve here as a safety device, and some on ships you have PV valve on top of the cargo tank. Again, a safety device to avoid excess pressure in the cargo tank. We are aware of this fresh air inlet line for the purpose of the fresh air inlet line, and yes, so we understand that it is there. The line can be used when the IG system is not in use. We can, if we need to gas free any tank, we can use the same system, same pipeline diagram for gas free purposes also. So in case the oxygen percentage is quite high, this regulating valve does not allow the gases to go to the cargo tank, and instead it starts recirculating these gases till the oxygen assigned oxygen percentage is achieved. Then only this regulating valve starts opening and allowing these inert gases to go to the, and nowadays many ships, that previous diagram as we have seen, there is a line going to the funnel from here. Instead of recirculating, the gases are going up to the funnel, going out from the funnel till the oxygen percentage is reduced to the required limit. Or if there is a set pressure, the operator can set the pressure for the cargo tank. There is a pressure regulating valve adjusted, works on that. We can assign the pressure not to exceed, for example, 500 mm water gauge in the cargo tank, not to exceed this much pressure. So when the operator sets the pressure, this regulating valve starts functioning. It takes the signal from this pressure transmitter and start functioning, and if it is open when the pressure is less than 500 mm water gauge, for example, I just take an example of 500 mm water gauge, it can be any figure, but 500 mm, suppose I set it to 500 water gauge, then pressure regulating valve will function so that the pressure in the cargo tank not to exceed 500 mm water gauge. So if the pressure reaches to 500 mm, this valve will close and the valve to the funnel will open and all the gas will start going out from the funnel. Or as per this diagram, it will start recirculating till the pressure comes down in the cargo tank, and then it will start slowly, it will start opening and maintain the pressure in the cargo tank not more than 500 mm water gauge as been set by me, by the operator. So that is why it is called pressure regulating valve. It is doing the dual purpose. First is managing the oxygen percentage. High percentage of oxygen is not allowed to go to the cargo tank, so it's regulating that also. And not only that, it is also regulating the pressure which has been set by the operator to be maintained in the cargo tank. That is the maximum pressure set by the operator to be maintained in the cargo tank. So according to the set pressure, this regulating valve opens and shuts so that the pressure can be maintained in the cargo tank. Another safety device. So that's how it works, and it can be used for, there are two blows, inert gas blows 1 and inert gas blow 2. combined capacity of this be as per the SOLAS discharge capacity of this is the minimum requirement. Practically what is happening on board, each blower has a capacity of 1.25 times the maximum discharging capacity of the vessel. So practically each blower is complying with the SOLAS regulation, whereas the SOLAS regulation says combined the blower minimum 2 blowers should be there, and the combined capacity of these 2 blowers should be not be less than the maximum discharging, at least 1.25 times the maximum discharge capacity of the vessel. You have the valves provided on the suction side and the discharge side of the blowers. Reason being, if there is no valve and if I'm using this bottom blower, the IG from this scrubber will come and go towards the tank from here, and if there is no valve, the chances that it might go back. So that's why it is a requirement as per the SOLAS to have a valves on the suction and the discharge side of the blowers. Then you have a pressure regulating valve, then you have the deck seal, then you have NRV, non-return valve, deck isolation valve. Then if you need to have a there's a IG drain here just to check if there is no water being carried in the IG line, or you want to take the sample, or you want to measure the oxygen percentage of the IG. These drains are used to check the oxygen percentage which is going to the cargo tank. Then you have a PV breaker which works to avoid excess pressure in the cargo tank, and then it finally goes to the cargo tank. From the top of the tank it enters the cargo tank. In the cargo tank, the vapors has to be removed from the airspace, has to be the whatever vapors are there, inert gas which is there has to be removed. Then only the oil can occupy the space, otherwise it will rupture the tank. The pressure will start increasing. So for that purpose, these vapors also, while loading, these vapors comes out from here and goes out through the masterizer to the atmosphere. That is the venting arrangement, which is the IG main line is also used for venting arrangement, venting the inert gas while loading in the cargo tank. So you have third safety device in the form of breather valve. So in case the PV valve fails, in case the PV breaker fails, then you have another safety device as breather valve. At certain set pressure, this valve is also will release the excess pressure in the cargo tank. The main idea of all these safety devices is to protect the cargo tank from rupturing, from damage. We cannot afford to have an excess pressure in the cargo tank. 0.5 bar is quite a lot of pressure. The cargo tank might rupture at 0.5 bar of pressure, 0.5 bar approximately, and 1000 water gauge is equivalent to 0.1. So that is why such a sensitivity of the pressure we cannot exceed. They are not designed, these cargo tanks are not designed to take excess pressure, only 0.5 bar. So we cannot afford to have excess pressure. That is why so many safety devices are installed in the system to release the excess pressure in the cargo tank, so that it should never reach that pressure where it ruptures, where it can damage the cargo tank. That's how the inert gas system functions. Any question?
Sir, this breather valve, it operates
Automatically. All this which is there, PV valve, PV breaker and breather valve, they work automatically. And instead, and on top of this, there's one more safety device, the alarm system. Each tank has its individual pressure sensors. Each cargo tank is being installed with a pressure sensor inside the cargo tank. Each cargo tank has this, and this signal of this pressure sensor are going towards the cargo control room, and it has a alarm system. So if the pressure is exceeding, it will give the alarm also. So many safety devices are in place in the form of PV valve, PV breaker, breather valve, and then you have an alarm system, audio and visual alarm. If the pressure exceeds 10% more than the PV valve, the alarm will be activated in the cargo control room as well as on the bridge.
Sir, is there any requirement that PV valve should lift first, or PV breaker should break first, or breather valve should lift first, or it depends on the ship manufacturer?
Usually it's a requirement the PV valve should lift first, then PV breaker. Breather valve is not a requirement as per the SOLAS, but in addition you can always exceed more than the SOLAS requirement, but SOLAS says only PV valve and PV breaker, and PV valve should lift first and then PV breaker.
Okay, sir.
Right.
Sir, while loading, do we need to operate these PV valves by ourselves, or should we wait? I mean, do we let them operate by themselves, or should we open it by?
What happens is when you're before loading, this is part of the there's a pre-arrival checklist for the cargo operation. If you go through this, if you go through that pre-arrival checklist, it is mentioned there that PV valve should be operational. So it is necessary to operate them before loading so that it will function. But during loading, when you have a conventional venting system which is venting through the pasteurizer in a conventional crude oil carrier and a product carrier, there you don't leave it open, it will open on its own. Okay, you're not supposed to open it, keep it open and put a rope or something. Some people do it. It's not allowed. It will open at certain pressure, set pressure, it will activate.
Sir, in all ships, like I was told that this thing PV valve does not operate properly, so they will operate it by this thing manual. They open it and then do
What
it.
happens is in those ships, the maintenance of that, it all depends on maintenance of the equipment. People perhaps are not maintaining these PV valves properly, not doing the PMS schedule, not following the plan and maintenance schedule for the PV valve. So nobody is doing any maintenance on these PV valves. So when you're not doing any maintenance, it will not open. It might get rusted and all. It may not open at a set pressure. So under such circumstances, you have to open. You have no choice. Otherwise, but it is not designed for that. You're not supposed to open it.
Yes, sir.
Any other question? All right. So we proceed further. Scrubber unit. The purpose of scrubber unit is to cool the flue gas. Refer to the diagram that you have drawn where is the location of the scrubber unit. We'll see how it works. The function of this scrubber unit is to cool the flue gas, remove suspended solid particle from the gas, remove sulphurous gases, to clean the flue gas of particulate soot. So this is the function of whole cleaning, all treatment of the flue gas is done in the scrubber tower, and all the above actions are achieved by direct contact between the flue gas and a large quantity of seawater. What happens? This is a diagram of the scrubber tower. You will see here the boiler. From the boiler, the gases are entering the scrubber tower at the bottom. Even in the diagram also, in your the diagram you have just drawn, it is showing that the gases are entering at the bottom of the scrubber tower, and this pipe is submerged in a pool of water inside the scrubber. So when the gases passes through the pool of water, some cooling is done and some solid particles are already removed in the gases from the flue gas. After that, it comes out from there. It is above the bottom. It's hanging. It's above the certain distance so that it bubbles through the water. So some cleaning and some cooling is done in this pool of water, and this pool of water, you will see this water inlet. The seawater supply is done to the scrubber tower. There is seawater scrubber pumps are there which are continuously supplying seawater to the scrubber tower when the IG system is working. So the supply is from here. It comes down in the form of jets under high pressure. There's so many jets are there, and all the water is coming down from here, and there is a drain line, and all it is getting drained straight going overboard. So water from there, this water comes down in the form of a spray or a jets, and once it passes through different stages, it is finally goes direct to the overboard. That's how the seawater travels in the scrubber tower. Now what is happening in the gases are the flue gas, hot flue gas are entering at the bottom of the scrubber, passing through bubbling through the pool of water, passing through the venturi slot. What happens? The speed of the inert gas, as the word itself describes, the venturi effects takes place. The velocity of the gases increases due to the reduction in the diameter of the area, and with this the solid particles falls down. Solid particles which are there in the gas are removed in the venturi slots. After that it passes, so all the solid particles are removed here in the venturi slots because of the venturi effects. As you know what is the venturi effect, as the diameter is of the pipe reduces, the speed of the flow of the gases increases because of the Bernoulli's theorem. So as the velocity of the gases increases, the solid particles cannot cope up and they fall back. So here the solid particles are removed. After this first stage, after passing through the second stage, the gases passes through the impingement plate, the baffle plates. They're known as impingement plate. They are baffle plates at a different, as you can see in the diagram, the gases are passing through a zigzag path and coming out. And the water from the top also is passing through the same hole and it's coming down. So the maximum cooling of the inert gas takes place in the impingement plate, and as it is coming in the contact of water, a pool of water which is falling from the top in the form of spray, and the water is passing through the same baffle place as going down, and the gases are going up and passing through the baffle place. So the cooling process happens in the impingement plates. These are baffle plates at a different level and covering each other, forming a zigzag path for the water and the gases. So the cooling comes down to around 5, comes down with the temperature of the gases are reduced to approximately 5 to 6 degree more than the seawater temperature. So much of cooling takes place in this scrubber tower, provided I have the set pressure of seawater as described in the IG manual. That's why good amount of seawater is required for cooling purposes. So this pressure has to be good. Certain pressure as described in the IG manual must be maintained for proper cooling. So the temperature comes down to more or less 5 to 6 degrees more than the seawater temperature, very close to seawater temperature. After cooling, after passing through the impingement plate, the gases pass through the packed tray. Here all the sulfur dioxide, particulate matters, very small tiny matters, solid particles are removed here, are absorbed here, removed here. So once it passes through the packed trays, the moisture level increases while as the gases are coming in contact with so much of water, the moisture content of the gases increases. So after passing through the packed tray stage, third, the gas is already cooled, it's already cleaned, but the moisture level of the gases has gone up. So for that purpose, it passes through the demister, absorbs the moisture which is there in the inert gas. So once the gas passes through the demister, the moisture level comes down as maximum amount of moisture is absorbed by the demister. And once it comes out from this scrubber tower, the gas is already cleaned, cooled and dried. So all the toxic constituents removed by the packed trays. Cooling is done in the impingement plates. Solid particles are removed in the venturi slots, and some cooling and cleaning is done when the gases pass through the pool of water. And once it's out from here, the moisture level is removed by the demister. So the gases, when they come out, they're already cleaned, cooled and dried, and continuous. You must have seen, those who have worked on a tanker, crude carrier, while discharging, if you go towards the engine room side, if you see overside, you will see some black water coming. Has anybody observed this?
Yes, sir.
So that black water is coming from the scrubber tower. Why it is black? Because of the solid particle, because of the soot, because of the sulphur. It looks like sometimes it's so black, so it looks like this oil coming out. So if it is too much of black is there, it's good idea to tell the engine room. They can increase the pressure on the scrubber tower, so that the initial stage, especially, too much black soot comes out.
So is it okay to discharge this water directly without treating?
That's right. It's not a pollution. It is acceptable.
Okay.
So when you see this, when taking a round, it's a good observation. Next time when you go on board,
इसमें जो ये वाटर
See, for nitrogen generators, if you have generators, then it's okay.
बट
But
वहाँ पे
here,
भी इसके लिए था सर, तो बट उसमें बोल रहे थे कि ये हो जाया था।
उसमें क्या होगा? So same, they must be sitting in the scrubber tower only. Same water, special provision provided. And when you're using the IG generator or nitrogen generator, they are not so dirty, not so black. Soot is not there. This scrubber tower is used for when you're using the boiler uptake soot, boiler uptake flue gas, which is very dirty, which is full of soot. And if you have a nitrogen generator, it's generating nitrogen, there is no soot at all. So in those cases, scrubber tower is just cooling it. Maybe it's getting heated and it's just for the precautionary sake is passing through the scrubber tower for cooling purposes, which also does not require. So in such cases, when there is a requirement that scrubber tower you cannot pump it out or something, there you can avoid using it, or you can use the same water, you can circulate the same water for cooling purposes. But when you have this kind of system where you're using the uptake from the boiler, this soot has to go over water. You cannot avoid it. There is no closed system here, or there is no system provided where you can circulate this water. It's very dirty water, you're not supposed to circulate. Okay, so for nitrogen generators, this is just for the cooling. Nothing is required. It's just for small cleaning, perhaps not even cooling. Nitrogen generator is generating nitrogen which is already cooled. But here I'm
मेड बाय दिस प्रोसेस ओनली सर, वो बॉयलर से ही गैस लेके ही नाइट्रोजन बनता था उसमें।
अच्छा, these are the contents of IG flue gas that is coming from the boiler uptake. Nitrogen is 83%, carbon dioxide 12 to 14%. These are the contents of inert gas when it is coming from the flue gas. But when you are using nitrogen generator for generating nitrogen, which is used on the chemical tankers, we don't use the fuel boiler uptake, boiler exhaust. No, that boiler exhaust will react with because there are other gases also. But when we are putting pure nitrogen, 99% of nitrogen in the cargo tank, this is a special generator. We cannot use the boiler exhaust for this purpose. No, because there are other gases also, other solid particles also, which might react with the chemical. This is, you are talking about chemical tanker, right?
तो मतलब मैंने पढ़ा, स्टडी किया था, तो उसमें सब में ये सारी गैसेस रुक जाती हैं और सिर्फ नाइट्रोजन पास होती है, वो तीन।
But for chemical tanker, we cannot use the flue gas from the boiler and use it on the it will react, वो damage कर देगा सारा chemical. So when you see that black smoke, black soot, black water coming when you go for a round, before you take over watch, this is one other thing you must check, whether there is water coming out. If it is too black, it's a good idea to tell engine room बहुत ज़्यादा black आ रहा है, so they can adjust the air supply or increase the water pressure and reduce the soot which is going out to the overboard.
और sometimes sound is also coming in pipes.
क्या
आवाज भी फील होती है पाइपलाइंस में, जब आईजी पाइप में।
अच्छा, so you must
लेकिन ये कंट्रोल करना तो सर इंजीनियर्स का काम है ना।
क्या कंक्लूड करना? All the black soot, all the cleaning shit is also going out overboard to the sea. That's why you see a black water sometimes towards the engine room side when the IG system is running. Those who are working on the tanker, if you're not absorb this next time, try to observe when you're taking a round before taking over watch. Check on the overside near the engine room, over and starboard. You will see some black water coming out. That is coming out from the scrubber tower. Okay.
Sir, can you please revise the scrubber tower flow process, sir, quickly, and what each of these layers does? I just want to make sure I've written it right.
What happens? This gas inlet, if you look at the diagram that you have drawn, this gas inlet is coming from the boiler uptake. It's going at the bottom of the scrubber tower. There is a continuous seawater supply to the scrubber tower for cleaning and cooling purpose. That plays the most important part. So there are scrubber pumps. 2 pumps are there dedicated only for the scrubber tower, known as scrubber pumps, seawater pumps. They are basically, they're supplying seawater while the IG system is in working state. So this seawater supply, the water is falling from the top of the scrubber tower in the form of jets and spray for cooling and cleaning purposes. And there is a pool of water at the bottom of the scrubber tower, and the pipe is immersed in that pool. So when the inert gas, the hot flue gas coming out from the boiler exhaust, bubbles through the water, some cooling and some cleaning, some solid particles are removed. After that, it passes, these gases pass through the venturi slots where the solid particles, all the solid particles including soot and particulate matters are removed. Particulate matters are very tiny particles, solid particles which remain suspended in the atmosphere. So all the solid particles are removed from the venturi slots. After that, it passes through the second stage, the third stage. First stage is this, second stage, third stage. The gas passed through the impingement plate, and water is continuously falling from the top and also passing through this impingement plates. This impingement plate is the baffle plates which one above the other and forms a zigzag path for the water from the top to follow and drops down, and for the gases to pass through and go up. So in the impingement plate, in this stage, gases comes in contact with the water, and the maximum amount of time they come in contact with the water. So whole cooling is performed. Cooling of the temperature drop is done in this stage, and temperature is dropped to more or less 5 to 6 degrees above the seawater temperature. After cooling, it passes to the patch tray where all the toxic gases, toxic elements, sulfur dioxide, all these elements, NOx and SOx are removed. But as the gases are coming in contact with the water, the moisture level of the water increases. So to remove the moisture, the gases pass through the demister, where demister absorbs all the moisture from the gas and comes out from the scrubber tower and is sucked by the IG blowers. Alright.
Thank you, sir.
Right. So next item is deck seal. Purpose of the deck seal water is to prevent feedback of hydrocarbon from the cargo tank via the inert gas deck main to the engine room and to the boiler uptake. The purpose of the deck seal is to avoid the hydrocarbons or the vapors from the cargo tank to go back to the engine room. The reason being, engine room is a safe area and deck is a hazardous area. Engine room is a safe area, that's why we are running all the machineries, we are doing all the hot work, we are running boiler, we are running main engines, so much heat is generated, so much oxygen is there. So only thing which is missing there for the fire to take place are the cargo vapors, hydrocarbon vapors. So if we allow these vapors from the cargo side to go towards the engine room, your triangle will be completed, your fire triangle, and the chances of fire and explosions definitely take place. So small leakage of hydrocarbon gas can build up to the dangerous concentration over a period of time. Since a mechanical, you have another non-return valve. If you look at the diagram, NRV, mechanical non-return valve. Due to the acidic nature of this inert gas, it corrodes the metal and eats up the rubber packings. So with time, this mechanical non-return valves tends to leak, tends to allow these hydrocarbons to pass through them. It doesn't give the 100% guarantee that it will function, it will perform the work he's assigned to, not allow these hydrocarbons to pass through. But with time, with age, due to the acidic nature of the inert gas, this NRV, mechanical NRV, will allow the small concentration perhaps to pass through, whereas deck seal works as forms a water seal. With age also, it will not affect the water seal, nothing will happen to the water seal. So it's 100% guarantee that this hydrocarbon will never ever pass through this water seal. So that is why deck seal is much more reliable than the mechanical non-return valve, and solves the purpose that it will never ever allow these cargo vapors to pass through this deck seal and go towards the engine room. That is the purpose of the deck seal. There are three types of deck seals: dry, semi-dry, and wet type. This is for your information. 1000 of water column is equal to 0.98 bar, which is equivalent to 0.1 bar. Practical purposes, it is equal to 0.1000 of water column, 1000 of water gauge. The pressure is equivalent to 0. We all know how much is 1000 m water. 1000 ho gaya pressure. Those who have worked on a tanker, it's quite a lot. We need to release some gases. This pressure is going up, but actually, practically speaking, is equal to 0.1 bar, and a cargo tank can withstand only 0.5 bar. That's why you have so many pressure release system, safety devices installed on the system to keep the cargo tanks safe, keep the cargo tank away from the damage, protect them from the damage. 3 deck seals are there: dry type, semi-dry, and wet type. I think we can stop it here, or we do one wet one. We do one and then we stop. We will repeat the same thing again in the next class. This is wet tank. Pay attention. This is the gas flow towards the cargo tank. This is the engine room side where you see my arrow, and this is the deck side, which is going towards the deck and going towards the cargo tank. Here also, from the IG blower, if you look at the diagram, from the IG blower, these gases are passing through the pressure regulating valve and then entering the deck seal. There is a pool of water again. The pipe is submerged in water, but it is above the bottom. So bubbles again, the gases in the normal IG mode, normal operation. In a normal operation, what is happening? The IG coming from the engine room, from the IG blower, and passing through the bubble of water. Here also there is a continuous seawater supply. It's known as deck seal water pump, deck seal seawater pump, deck seal pump basically. As we have seen in the SOLAS requirement, there's supposed to be 2 pumps should be there. One pump is running and another pump should be standby, continuously running. This pump is running all the time, whether the ship is at anchor, alongside, or out at sea. This pump is running all the time and providing seawater to the deck seal and maintaining the level of water at all times. There is an overflow line, and then when it reaches the overflow line, this water is going directly overboard. This pump is running while at sea also continuously, so that because this level has to be maintained, this water level has to be maintained in the deck seal, then only it will form the seal, then only it will function. So whether the IG system is running or not running, this deck seal water pump is continuously running, whether the ship is at alongside, in a ballast condition, loaded condition, loading, discharging, sailing, out at sea, middle of the ocean. This pump is running all the time and is maintaining the seawater level in the deck seal. So when you have a normal operation, IG from the engine room pass through the bubble of water and go up towards the cargo tank. Normal operation. But when the IG system is not working, there are chances that you have the cargo vapors from the cargo tank will start coming to the deck seal and exert the pressure on the surface of the water. As the pressure increases on the surface of the water, this water starts entering into the pipeline. As the pressure keeps increasing, the water level in the pipeline also keeps increasing, and there is a continuous supply of water. The level of the water is maintained. So under any condition, it will never allow these gases to bubble through and pass through this and go to the engine room, because there is a huge amount of water in the pipeline and the pressure is not so much that it will exert and bubble through the water. So that is why it is forming the seal. It is not allowing the water, the cargo vapors from the cargo tank to go towards the engine room. As the water level, as the pressure is increasing on the surface of the water, the level also is increasing. So it becomes impossible for these vapors to bubble through and pass through this and go to the engine room. So it is 100% guaranteed that these vapors will never go to the engine room as long as I maintain the water level in the deck seal. Any question? Okay, we stop it here. We will repeat it again. Hope you guys have drawn the diagram, and we'll repeat it again next time when we start with this continuation of this IG system. But if you have whatever questions you have, keep it to yourself, and then we will discuss them. Okay, thank you very much, everyone.
Sir, could you please send the notes?
Okay, I will send it again. Thank you, everyone.
Thank you, sir.